Hi everyone, in this episode we're going to create scriptable objects to hold the planet's shape and color settings. We'll have a custom editor to display these in our planet's inspector, and have any changes to them cause the planet to update automatically. The reason for doing it this way is that later on it will be extremely easy to save the shape and color settings for planets that we generate and load them in as we want. Alright, so in Unity I'm going to create a new C# script, call this shape settings, and then a second one called the color settings. Alright, I will open this up. These are both going to inherit from scriptable object so that we can create actual assets out of them, and I'll just have this create asset menu attribute up at the top here. Shape settings, it will eventually have loads of stuff, but for now let's just have a public float for the planet radius. I'll set that to maybe 1 by default, save that, and open up the color settings file. So this inherits from scriptable object, and once again have this create asset menu attribute up here. And for now this can just hold a public color for the color of the planet. Alright, so if we save this, go into Unity and just wait for that to compile, then when we right click, under the create menu we'll now have our shape and color settings. I'm going to create a new folder first though, call this settings, and then inside there I'll create a new shape settings, let's call that shape, and a new color settings, which I'll call color. Alright, in here we can then set the color of our planet, as well as the radius, like so. Of course, these settings currently aren't linked to anything, so let's go back into the planet script, and this is going to have a public shape settings, as well as a public color settings. Alright, then coming down here, along with the generate mesh method, let's have a generate colors method. For now this is just going to loop through the meshes and set the material's color to the color we have in our settings. So I'll say for each mesh filter, just call that M in the mesh filters array. We need to get its mesh renderer component, which you can do like so, and then set the shared material color equal to color settings dot planet color. Alright, we can then have a public void on color settings updated, where we first call initialize and then generate colors. We'll also have a public void for when the shape settings are updated, and here we'll call initialize followed by generate mesh. Now, generate mesh is calling this construct mesh method on each of the faces, so we need to get that to use the planet radius from our settings. So we could simply give each terrain face access to the shape settings, but of course later on the shape generation is going to be a little more complex than just the radius. So I'm going to go ahead and create a new C# script, which I'll call the shape generator. And then I'll open that up. And this isn't going to inherit from mono behavior, and it's going to have a shape settings object here, which can be assigned in the constructor. And then it's going to have a public method returning a vector3. I'll call this calculate point on planet, and we'll take in a vector3 point on unit sphere. Alright, so at the moment this method will just be very simple. It will return the point on the unit sphere multiplied by settings dot planet radius. Okay, so I'll save that, go into the planet script, and here we'll want a shape generator object, call that shape generator, and in initialize we can just set that equal to a new shape generator and pass in the current shape settings. Alright, now we'll want each terrain face to have access to that shape generator, so I'll just pass it in as an argument here, shape generator, and then we'll need to go into the terrain face to actually update the constructor. So I'll add the shape generator as the first parameter here. Okay, I'll quickly copy that so that we can have a reference to it outside of the constructor. And then just assign that in here. This dot shape generator is equal to the given shape generator. Alright, then when we're assigning to the vertices here, we can say vertices I is equal to shape generator dot calculate point on planet, passing in the point on the unit sphere. Okay, going back to the planet script quickly, I'm going to create a public void generate planet, and this will call initialize, it will call generate mesh, and it will call generate colors. So basically, this is the method you want to call to generate the planet, but if only the shape settings have changed, then you can call this method, and if only the color settings have changed, you can call this method. Alright, so coming up to our onValidate thing here, let's just call generate planet. So I'll save that, and if we go into Unity, we'll probably get some errors when this tries to generate the planet, but it doesn't have the shape or color settings assigned yet. So let's go into the settings here and just assign both of these quickly. And now you can see that this is green, as defined by our color, and it has a radius of 2. So if we change this to red, you can see it doesn't actually update immediately. We have to go onto the planet and actually trigger the onValidate method by doing something like changing the resolution. Now, that's obviously not ideal. What I would like is for, first of all, the shape and color settings to be editable right here in the inspector of our planet object, and secondly, for any change to those settings to immediately update the planet. So, to achieve this, we're going to need a custom editor. So let's create a editor folder, and inside of there, go to create a new C# script called the planet editor, and I'll open that up. Alright, so up at the top here, we can say using Unity editor, and we can inherit from the editor. And let's just say that this is a custom editor, type of planet, and then we can have a reference to our planet, which we'll set in the onEnable method by saying planet is equal to, and then casting the target object to a planet, like so. We can then override the onInspectorGUI method, and then we'll want to draw an editor for the shape and color settings. So I'm going to make a method called drawSettingsEditor. This will take in an object for the settings object, and we can for now simply say editor is equal to, and we can create a new editor passing in the settings object, and then to display it we just call editor.onInspectorGUI. Okay, so from this onInspectorGUI we can call drawSettingsEditor, passing in planet.shapeSettings, and then drawSettingsEditor again, this time passing in the color settings. Okay, so if we save this now and go into Unity, then once this finishes compiling, we should see over here we have our shape settings, and we can change the planet radius right there, and we've also got the color settings, and we can change the planet color here. Now, of course, this isn't updating automatically just yet, so let's go back into the script here, and we can check if anything in the editor has changed in the following way. We say using, then we create a variable called something like check, set this equal to a new editorGUI.changeCheckScope, and then at the end of this we can say if check.changed, then obviously something has changed. So in here we'll want to call the planet's onShapeSettingsUpdated or onColorSettingsUpdated method, depending on which settings object we're currently drawing. So in the method parameters here, let's add a action, which I'll call onSettingsUpdated, and then in here we can just say if onSettingsUpdated is not equal to null, then we will invoke that. And then up here where we're passing in the shape settings, we can pass in planet.shapeSettings, on shape settings updated, and where we're drawing the color settings, planet.on color settings updated. Alright, let's save that and go into Unity. And once that compiles, we can now change the planet radius, and we see that updates immediately, and same story with the colors. Alright, now currently it's not so clear where the different editors start and end, so let's make things a little clearer by drawing a title bar for each of them. So I'll go back into the Planet Editor script, and before we create the editor, we can just call editor GUI layout dot inspector title bar, and we can pass in a value of true and then our settings object. This value of true I'll explain in a moment, but let's just save that and go into Unity again quickly. So now we can see this is looking much nicer. But currently if we click on this little fold out arrow here, it's not actually hiding the editor as it does with, say, our planet script. And that is what this value of true is saying, is just that it's always folded out. So to make that work, let's add a bool fold out to the parameters here, and we can pass that in instead. And then this method returns a bool telling us the new value of the fold out in the case that the user's actually pressed the little arrow. So we can update the value by saying fold out is equal to the result of that method. Then obviously we only want to actually draw the editor if fold out is true. Alright, now this foldout value needs to be stored somewhere. We can't store it in our editor here because values aren't serialized here, which means it's going to keep losing its value. So instead we'll just store it in the planet script. I'll create public bool shape settings foldout, and don't want that to be displayed in the inspector, so I'll just add hide in inspector here, and I'll just copy paste that for the color settings foldout as well. Okay, save that, go back to the planet editor, and now over here we can pass this in. So I'll pass in planet dot shape settings foldout and planet dot color settings foldout. Alright, now in order for us to be able to change the value of the foldout variable that is actually in the planet class, we're going to need to have this bool passed in by reference. So let's add the ref keyword there, and we'll also need to add those two keywords in front when we call the method. Okay, so we should now be able to save this, go into Unity, and once this compiles, we should be able to control the foldout of our two settings editors. Alright, so the functionality that we wanted is now all there. There are just a couple of small changes I want to make. For one, I don't want toggling the foldout of the inspector title bar to actually trigger check.changed. So I'm just going to move this outside of the change check, like so. Then I also don't want to have to create a new editor each time we draw this, because that's a little bit inefficient. So instead, I'm going to define an editor outside here, call this the shape editor, and another for the color editor. Then in the parameters here we can have a reference to the appropriate editor, and pass the right one in here. So ref shape editor and ref color editor. Then instead of using this create editor method, we can use create cached editor. And here we pass in our settings. We can just use null for the editor type. That will just use the default editor type. And then we can pass in our editor by reference. So with this method, the editor that we pass in is getting saved up here, and it's only creating a new editor when it actually has to. Okay, let's also handle the case where the settings object hasn't been assigned in the inspector, and so it's null. So we'll only try and draw the settings editor if the settings object is not equal to null. Okay, then I'm going to copy this change check scope line, and I'm just going to surround this call to base.onInspectorGUI with that, and then here say if check.changed, then I'll call planet.generatePlanet. This is going to be replacing the onValidate method in the planet script, just so that all of the updating is being done from within the editor script. Then it might also be nice to have a button to just manually generate a planet. So if GUI layout.button, I'll call this generate planet. If that button is pressed, then we can call planet.generatePlanet. Alright, last thing is just in the planet script, I'm going to have a public bool auto update, which I'll set to true by default, and then we'll only run these on settings updated methods if auto update is true. Just like so. Alright, let's save that, and I'll go into Unity one last time to just make sure that this is all still working. So with auto update on, you can change the planet radius and the color of the planet, and that works fine. If I turn auto update off, you can change, say, the radius here, and then generate a planet manually, and that updates. Alright, so that is going to be everything for this episode. Until next time, cheers.